There is a difference between a ground fault circuit interrupter, or GFCI, next to a lavatory, or a GFCI protected can light in a shower and GFCI protected convenience outlets in a spa room. The primary difference lies in the categorization of these locations. Spa rooms are typically considered wet locations, while lavatories and showers are classified as damp locations. The National Electrical Code, or NEC, defines a wet location as an area where water is likely to be present on or around electrical equipment. Examples of wet locations include showers, bathrooms, and laundry rooms. In contrast, a damp location is defined as an area where moisture is likely to be present in the air, such as kitchens, basements, and crawl spaces. The NEC mandates that all electrical equipment installed in wet locations must be protected by a ground fault circuit interrupter. Ground fault circuit interrupters are designed to detect even small electrical leaks. They work by monitoring the current flowing through a circuit. If the current exceeds a certain level, indicating a potential ground fault, the GFCI trips the circuit, cutting off the power supply. This rapid interruption of power helps to prevent electrical shocks and fires. However, the NEC provides an exception to the GFCI requirement in wet locations. This exception applies to receptacles that are not readily accessible. Examples of such receptacles include those located behind fixed panels or appliances. The rationale behind this exception is that these receptacles are not easily accessed by people and therefore do not pose a significant risk of electrical shock. In the specific case of the spa room, if the convenience outlets are located on the exterior wall and are not readily accessible, they might not be required to be protected by a GFCI. It's important to note that the NEC does not generally require GFCIs in damp locations. Therefore, a GFCI protected can light in a shower, while a good safety measure is not typically mandated by code. The installation of GFCIs in damp locations, however, is a recommended practice as it provides an added layer of protection against electrical shocks and fires. Now, diving deeper into the NEC and its specific requirements, it's crucial to understand how to correctly interpret and apply the code. Firstly, always consult the latest edition of the NEC, as codes are updated periodically to reflect advancements in technology and safety standards. Secondly, pay close attention to the definitions provided within the NEC, as these definitions are the foundation for proper application of the code. Thirdly, consider the specific occupancy and environment when interpreting the NEC. The requirements for a residential spa room may differ from those of a commercial spa. The NEC has several articles that are particularly relevant to spa and hot tub installations. Article 680 covers swimming pools, fountains, and similar installations. While it primarily focuses on pools, it also includes provisions for hot tubs and spas. Some key sections within Article 680 include 680.42, which addresses general requirements for spas and hot tubs, and 680.43, which covers the wiring methods allowed for these installations. When installing electrical equipment near water, it's essential to use listed and labeled products that are specifically designed for wet locations. These products are constructed with materials that can withstand moisture and corrosion. Furthermore, ensure that all wiring connections are properly sealed to prevent water from entering the electrical system. Bonding is another critical aspect of electrical safety around spas and hot tubs. Bonding involves connecting all metal parts of the spa or hot tub, as well as any nearby metal objects, to a common grounding system. This helps to equalize the electrical potential and reduce the risk of electric shock. The NEC outlines specific bonding requirements in Article 680. In addition to GFCIs, other safety devices such as arc fault circuit interrupters, or FSIs, can provide added protection. FSIs are designed to detect arc faults, which are dangerous electrical conditions that can lead to fires. While not always required by code for spa rooms, FSIs are a valuable safety enhancement. Regular inspections are essential to ensure the ongoing safety of electrical installations in spa rooms. These inspections should be performed by qualified electricians who are familiar with the NEC and local codes. During an inspection, the electrician will check for any signs of damage, corrosion, or other potential hazards. They will also test the operation of GFCIs and other safety devices. Now let's talk about the practical implications of the 5-foot rule mentioned in the question. The 5-foot rule, as it's commonly called, refers to the area surrounding a spa or hot tub where certain restrictions apply to electrical equipment. Within this zone, specific requirements govern the type and placement of electrical devices to minimize the risk of electrical shock. The NEC outlines these requirements in Article 680. The 5-foot rule typically extends horizontally 5 feet from the inside wall of the spa or hot tub and vertically to a height of 7.5 feet above the maximum water level. Within this zone, receptacles must be GFCI protected, and certain types of lighting fixtures are prohibited. The purpose of the 5-foot rule is to create a safe zone around the spa or hot tub where the risk of electrical shock is minimized. By limiting the presence of electrical equipment in this zone, the potential for contact with energized components is reduced. It's important to note that the specific requirements of the 5-foot rule may vary depending on a local interpretation of the NEC. Always consult with a qualified electrician or local building inspector to ensure compliance with all applicable codes and regulations. Understanding the difference between wet and damp locations is crucial for selecting the appropriate electrical equipment and installation methods. Wet locations, as defined by the NEC, are areas where water is likely to be present on or around electrical equipment. These locations require special precautions to prevent electrical shock and fire hazards. Damp locations, on the other hand, are areas where moisture is likely to be present in the air, but not directly on electrical equipment. While damp locations do not require the same level of protection as wet locations, it's still important to use moisture-resistant materials and installation methods. When installing electrical equipment in wet locations, such as spa rooms, it's essential to use listed and labeled products that are specifically designed for these environments. These products are constructed with materials that can withstand moisture and corrosion. They also incorporate features such as watertight seals and enclosures to prevent water from entering the electrical system. In addition to using appropriate equipment, it's also important to follow proper installation techniques. Wiring connections should be made in a way that prevents water from entering the junction box or conduit. Conduit should be properly sealed to prevent moisture from accumulating inside. When working with electrical equipment in wet locations, always disconnect the power supply before beginning any work. Use appropriate safety gear, such as rubber gloves and insulated tools. If you are not comfortable working with electricity, hire a qualified electrician to perform the work. Now let's discuss the exception to the GFCI requirement for receptacles that are not readily accessible. As mentioned earlier, the NEC allows an exception to the GFCI requirement for receptacles that are located behind fixed panels or appliances. The rationale behind this exception is that these receptacles are not easily accessed by people and therefore do not pose a significant risk of electrical shock. However, it's important to understand the limitations of this exception. The exception only applies to receptacles that are truly inaccessible. If a receptacle can be easily accessed by removing a panel or appliance, it is not considered inaccessible and must be GFCI protected. Furthermore, the exception does not apply to receptacles that are located within the 5-foot zone around a spa or hot tub. Within this zone, all receptacles must be GFCI protected, regardless of their accessibility. When determining whether a receptacle is considered inaccessible, it's important to consider the likelihood that someone will need to use the receptacle. If the receptacle is intended for occasional use, such as plugging in a portable appliance, it should be GFCI protected. If the receptacle is only intended for use with a permanently installed appliance, it may be eligible for the exception. Ultimately, the decision of whether to GFCI protect a receptacle is a matter of engineering judgment. Consider the specific circumstances and err on the side of caution. If there is any doubt about whether a receptacle should be GFCI protected, it's always best to install a GFCI. GFCIs are relatively inexpensive and can provide a significant level of protection against electrical shock. In addition to the NEC, local codes and regulations may also apply to electrical installations in spa rooms. These codes may be more stringent than the NEC and may require additional safety measures. It's important to check with your local building department to determine the specific requirements for your area. Building inspectors are responsible for enforcing the NEC and local codes. They will inspect electrical installations to ensure that they comply with all applicable regulations. If an installation does not meet code, the inspector will issue a correction notice. It's important to address any correction notices promptly and to work with the inspector to ensure that the installation is brought into compliance. Compliance with the NEC and local codes is essential for ensuring the safety of electrical installations in spa rooms. By following these regulations, you can minimize the risk of electrical shock and fire hazards. Remember, when in doubt, consult with a qualified electrician or local building inspector. They can provide expert guidance and ensure that your electrical installation is safe and code compliant. Also consider, it is beneficial to consider having a dedicated circuit for the spa or hot tub, meaning that the circuit breaker in the electrical panel only serves the spa or hot tub. This can help prevent overloading the circuit and reduce the risk of electrical problems. Also, surge protection can help protect the electrical equipment associated with the spa or hot tub from damage caused by power surges. Surge protection devices can be installed at the electrical panel or at individual outlets. If the spa or hot tub has a heater, be sure that the heater is properly grounded. This will help prevent electrical shock if the heater malfunctions. Never use extension cords with a spa or hot tub. Extension cords are not designed to be used in wet locations and can pose a serious electrical hazard. Make sure that the spa or hot tub is properly ventilated. This will help prevent the build-up of moisture and reduce the risk of electrical problems. Regularly inspect the electrical components of the spa or hot tub for any signs of damage or wear. If you notice any problems, have them repaired immediately by a qualified electrician. And lastly, if you are planning to install a new spa or hot tub, be sure to obtain the necessary permits from your local building department. This will ensure that the installation meets all applicable codes and regulations. When considering lighting around spas and hot tubs, it's crucial to use fixtures that are specifically designed for wet locations. These fixtures are constructed with materials that can withstand moisture and corrosion. They also incorporate features such as watertight seals and enclosures to prevent water from entering the electrical system. Furthermore, lighting fixtures should be installed in a way that minimizes the risk of electrical shock. Fixtures should be mounted at least 7.5 feet above the maximum water level, or they should be GFCI protected. It's also important to avoid using metal lighting fixtures near spas and hot tubs. Metal fixtures can become energized if there is a fault in the electrical system. Plastic or composite fixtures are a safer alternative. Low voltage lighting is another option for lighting around spas and hot tubs. Low voltage lighting systems use a transformer to reduce the voltage to a safe level. This reduces the risk of electrical shock. Fiber optic lighting is another safe and energy efficient option. Fiber optic lighting systems use a light source that is located away from the spa or hot tub. Light is transmitted through fiber optic cables to the desired location. This eliminates the risk of electrical shock near the water. Ultimately, the best lighting solution for spa or hot tub will depend on the specific circumstances. Consider the desired aesthetic, the level of illumination needed, and the safety requirements. Consult with a qualified electrician to determine the best lighting solution for your needs. Lastly, remember that safety is paramount when it comes to electrical installations around spas and hot tubs. By following the NEC and local codes, and by taking the necessary precautions, you can minimize the risk of electrical shock and fire hazards.